Alright, so what we're looking at today is the third day of lesson 4.1, okay, solving systems of equations. Now, what you're going to look at today is more application problems, which is really, really good because that's how you're going to see a majority of these on the EOC. Alright, so let's look at this first problem. We're going to solve this system using a graph, okay, and we're going to use our calculator like we've been doing, so it's not anything different. Okay, so what's the problem that we're solving? Here's what it is. One mountain climber is 7 feet below a ledge climbing up the mountain at a rate of 3 feet per minute. A second mountain climber is 7 feet above the same ledge and descending, which means what? Going down at a rate of 0.5 feet, feet per minute. When are the two mountain climbers at the same height relative to the ledge? So let me draw you a picture. Pictures always help the understanding of a problem. Here's my height, right? So like I'm going up and down on my y-axis, and I'm going to say this is the ledge, right? And that is my x-axis, is the ledge. So the first situation says one mountain climber is 7 feet below this ledge. So 7 feet below it would be like your -1 feet, -2, -3, -4, -5, -6, -7 on the y-axis. And he's climbing where? Up or down? What does it say? It says that he's ascending, which means coming up, okay, at a rate of 3 feet per minute. So I'm going up at a rate of 1, 2, 3 feet per every 1 minute, 2 minutes, 3 minutes, 4 minutes, and so forth. So he's going up every 1, 2, 3 feet per 1 minute. Up 1, 2, 3 feet per 1 minute. Up 1, 2, 3 feet per 1 minute, and so forth and so on. So his climbing rate or height kind of looks something like this, to where he's going up at that rate. Can I write an equation for that? Sure you can. What's the rate? The rate is the same thing as the slope. So what's the slope of this line? It's 3. What is the y-intercept of this line relative to the ledge? It is he's 7 feet below this ledge. So that would be a -7. So if I wrote that climber's rate as an equation, it would be y is equal to, can y'all tell me? 3x plus 7? -7. Very good. Okay, so let's write an equation and let's get a picture of the second mountain climber. A second mountain climber is 7 feet above that same ledge. Okay, so we have to say that this one is above the ledge by 1, 2, 3, 4, 5, 6, 7, like that. So this is where that one starts. This is where this one starts. Except this one is descending, which means coming down at a rate of 0.5 feet or 1/2 of a foot per minute. You follow? So 0.5, would you agree, same thing as 1/2? And if that's my rate, that's the same thing as my slope. That's the rate at which he's going down, so it's really -1/2 feet per minute. So that would be my rise, which is going down 1 foot. From here, he's going down 1 per every 2 minutes. So I go down 1, right 2, down 1, right 2, and so forth and so on. And I want to figure out if they go at that rate, at what point in time would they be the same height? Where is that point right there? Y'all follow? Okay. And that point right there would be how far above the ledge or below the ledge. That's what we want to figure out. So what's an equation for this line? It would be y is equal to the slope. What's the slope of that line? It's the rate of change, which is what? -1/2 x. And then my y-intercept is here, which was at a positive what? 7. Okay, so how do I do that? Well, all we do is follow the directions. Now, these directions are a little bit different. How do we graph in this calculator? To graph in this calculator, to find out where they intersect, I go to my home screen, go to New Document, don't save my last, and then add these graphs of these functions. Graph the first one, which is 3x what? -7. then graph the second one, which is negative 1/2 x plus 7. Now, how do I graph the second one on the same screen? What do I hit now? Y'all tell me. Tab. And then a negative 1/2 x plus 7. And then hit enter. And where would they cross? So I go to menu, analyze graph, find the intersection. Move it to the left of the intersection, to the right of the intersection, and there it is. It's kind of hard to see. So let's take our little hand, put it on top of that 4, whatever it is, and then hold down the middle of my little mouse pad and move it over here so I can see it, and let go by hitting the middle of it and moving your hand out of the way. Where would they cross? 4, 5. So that intersecting point is where? 4, 5. Now what does that mean as it relates to the problem? What does that mean as it relates to the problem? What is X talking about here? Wasn't that what? Minutes? Right? It's feet per minute. And so what's Y talking about? The feet. So here's my X, here's my Y. What is X? Minutes. What is Y? Feet. So can you explain to me in words, when are the two mountain climbers at the same height relative to the edge? When? In what?
4 minutes.
Very good. In 4 minutes, both climbers are what? Are what? 5 feet above the ledge. You got it? And that's it. So let's see if we can do problem B. One similar to it, just a little bit different. This one's talking about a boat. The equation, y is equal to negative 5x plus 6, and y is equal to negative x minus 2, represent the depth. Y is talking about the depth in feet of 2 anchors. Right? So you got a boat, they're going to drop their anchors. Okay, after x seconds, where x is greater than 0. Okay, so you can't have negative seconds, in other words. You can't go negative time. We're not going to have negative 1 second, negative 2 seconds, because you can't go back in time. You don't have a magic time machine, right? After how many seconds are 2 anchors at the same depth? So let's look at a picture of the problem. Doesn't that help? All right, here's the water. Here's boat 1. Right, and here's boat 2. Not a very good picture of a boat, but you get the idea. So boat 1 has its anchor 6 feet above the water at first, right? So maybe the anchor's sitting up here on deck. And then they're dropping the anchor, and it hits the water, makes a splash, and it's going down at a rate of what? Negative 5 feet per what? Second. How do I know it's negative 5 feet per second? Because the slope's negative 5. How did I know that this was 6 feet above the water? Because that's a positive 6. So this axis right here, which is my x-axis, also kind of represents the water line, doesn't it? So it's kind of the same thing. Thank you. All right, so we go with that. Now what does the second equation represent? Well, this is a negative 1, so that would be representing that the anchor's falling at a rate of what? 1 foot per second. Do you follow that? But what's this minus 2? What does that mean? It means that the anchor begins below the water level 2 feet. Does that make sense? So somehow this boat has an anchor that they can push a button and it's just down here below the deck and it starts going down. Maybe it's on a chain and goes down slower because it's going down at a rate of what? It's going down by 1 foot per second. And this y-intercept here is at negative 2. Y'all follow? So how can I get my calculator to get a picture of it? Well, I'll just graph these two functions. So cut on your calculator. Right, and we're going to go to New Document. Don't save my last one, and let's graph the first one. And it's in slope-intercept form. So I'm just going to add the graph, and I'm going to leave it in function notation. And it's going down at a rate of 5 feet per second. And x is the number of seconds that it's traveling, plus 6. So it's up here, it hits the water, and then it's going down. Right, my next anchor, so to graph a picture of that, I hit F, or hit Tab, and then I'm going to graph function 2. It's going down a rate of negative 1 foot per second, and there's no reason to put a 1 in front of the x. Minus 2. So it starts at negative 2. So it's below the water level down here, and it's going down at a slower rate. If I hit enter, okay, I can see that it's going down, 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 and then they both would be at the same height when? Right there. Now, why are they intersecting? Because this one's going down really fast. This one's going down really slow. So even though it was released higher, since it's going down faster, they would eventually be at the same point in time, at the same height at some point in time, because this one's going down slow, 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 slow. This one's going down fast. It's easy to see that they would be at the same height at what point in time. What is that intersection, or what is that x point in time that they would be the same height or the same depth below the water level? How do I calculate that? I find the intersection. So go to Menu, Analyze Graph, and I find the intersection, which is 4. And you have to see the intersection for your calculator to calculate it. So just take that little dash line, move it to the left of where you think the intersection is, and then move it to the right and hit enter. And if you can't see that point, once again, you can take your little cursor and put it on top of it until the hand shows up. Press the middle of your screen and hold it until the hand closes. And then I can move it and release it and see it. So what's the answer to this problem? It's at 2, negative 4. But what does 2 mean and what does negative 4 mean? What does x mean in the problem? This is the rate, right? So the rate in what? Seconds. In so many seconds, it is a depth of so many what? Feet. So answer the question. After how many seconds are the anchors the same depth? So I'd have to put this in words. After 2 what? The anchors are both, how deep? 4 feet below the water level. Okay? Below the water. You got it? So hopefully we understand that problem. Alright, let's go to one more application problem, and then we'll look at some types of questions that you could see on the EOC. Alright, so we looked at a problem like this yesterday. Or actually, we looked at this 2 days ago. Okay? You have 100 coins, and the value of those 100 coins are worth $6.95. That's it. All of the coins are nickels and dimes. How many nickels and how many dimes do you have? So we have to write a system of equations. So could anybody tell me one equation if I know that N represents the number of nickels that you have, and D is going to represent the number of dimes that you have? Can anybody write one equation from the information in the first sentence? You have 100 coins. So can somebody tell me one equation? If I have 100 coins and all of them are nickels and dimes, what would that be? The number of pennies plus the number of quarters is equal to 100. What would be my first equation then? The number of nickels, which is what? Plus, if I add the number of nickels to the number of, it's got to be equal to 100. That's the one we should all know. That's the easy one. The other one's harder. The other equation would be the value of the nickels plus the value of the dimes would have to be equal to $6.95. And so how do I figure out how many, or the value of the nickels I have if I had like 5 nickels? Or what if I had 7 nickels? What if I had 8 nickels? What if I had 20 nickels? How do I find the value of the nickels? That's what this is, the value of the nickels. So if I had 1 nickel, its value is what? 5 cents. What if I had 5 nickels? How'd you get that so fast? You're multiplying, aren't you? What are you multiplying? 5 cents. times what? However many nickels you have. So if I had 20 nickels, I'd just take 0.05 times 20, and that's how many dollars I have, right? That's the value of that in money, dollars, and cents, right? So what about the value of a dime? What do I do there? If I have 1 dime, it's worth 10 cents. What if I had 20 dimes? It'd be 20 times 10 cents, right? Which would be what? $2, right? So how do I find the value of that? I'm just taking the value of a dime, which is 10 cents, times however many dimes I have. There you go. Solve that system of equations now. How do I solve it? Well, the only way I know how to solve it right now is to graph it in my graphing calculator. But how do I graph this in my graphing calculator? I don't have N's and D's. So I'd have to say maybe this is X and this is Y. So the nickels is really X and the dimes are really Y. So just remember that. So somehow you got to write that down so you remember it. So cut on your calculator. And then what do? Go to my home screen. New document. Don't save my last one. How do I want to graph these? Okay, so if I add my graph, I don't want it in function notation. I have to graph edit my graph entries. So I don't want to enter this as a function. I want to enter it as a relation. So how do I do that? Hit menu, graph entry edit. So I want to edit how I'm entering in graphs. And I want to enter it as a relation. So what do I type? N plus D equals 100. What do? X plus Y equals 100. Enter. There it is, graph. Now let's graph the other one. I don't see it. Why don't I see it? Because it's way up here. It's okay. We'll see it in a minute. Let's graph our other one. How do I graph my second one? So if you look at it and go, I've had this question I don't know how many times over the last 3 days. My calculator's not graphing these. I'm like, yes it is. You just don't see it. You got to zoom out. We'll worry about that in a minute. Let's graph the other one. How do I graph the second function? Hit tab. See, it already graphed the first one. It's on there. Just don't see it. So then I have to type this in exactly the way it is. So it's 0.05, not N, but X, because X is my nickels plus 0.1 times Y, which is my dimes, is equal to what? 6.95. Hit enter. And that's graph 2. I don't see it. So how could I see it real easily? What did I tell you yesterday? Go to menu, window. So I'll change my window so I can see it. And so do I just hit zoom out? You could. But it might be faster to go to zoom fit and hit enter. Okay? I don't see the intersection, so it won't calculate it. So now maybe I can zoom out. So go to menu, window zoom. And let's just zoom out a little bit so I can see the intersection, because it won't tell me the answer unless I find the intersection. So I got to zoom out one more time, maybe over here somewhere. There it is. I see the intersection. I'm good now. See, I want to find out where they cross. Why do I want to find out where they cross? Because that tells me how many nickels and dimes I have that equal 100 and how many nickels and dimes that has that equal 6.95. That's when they would be equal. So I go to menu. Analyze graph, find the intersection, enter, enter. So just move that to the left and the right, and it'd be 6139. What does that mean? 61,39 is my solution, which means that's X and that's Y, but X was what? Nickels, and Y is dimes. So I have 61 nickels and 39 dimes to give me 100 coins, and the value would be $6.95. Wouldn't it? Let's check to make sure that that's right. Is it really $6.95? We know 61 and 39 is 100, right? So let's go to the calculator and let's see if that's right. All right, so we're going to calculate this real quick by taking 61 times a nickel, right? Nickel's worth 5 cents times 61, plus a dime is worth 10 cents, so it'd be 0.1 times however many dimes I have, which is 39. Hit enter. It better be 6.95, which it is. So we're good. We know it's right. We checked it. Okay, let's do these 4 problems real quick, just to make sure that we understand this lesson. We've spent 3 days on this lesson, so let's get this part right. The table shows the height of 2 trees that were planted in the same year. Both trees grow at a constant rate, so it means they're both linear. Which system of equations models this situation? So let's find an equation for tree 1 by using my x and my y's. How could you find an equation for that real quick in your calculator?
You can plug in the point.
Yeah, we can do a linear regression from chapter 3.8. Why not? We haven't done that yet. Let's use our calculator today to find an equation for this by going to your home screen, new document, don't save your last one, add lists and spreadsheets. I want to enter in an x and a y. So my x is really representing my time, my y is representing my tree height. So if I start off and enter my table, x is 0, 1, 2, 3. What's y? What is it? 3. All right, 4.5, 6, 7.5. And that would be tree 1. Hey, look, watch this. Let's go over here. I'm going to show you something pretty cool, too. I can do tree 2. Watch. I'm going to label that something else. Let's call that Z. Z. All right, so I got X, Y, Z. You can name it whatever you want. If you wanted to label that tree 2, you could. But I'm going to go ahead and enter all my data in. So I'm going to hit 6, enter, 7, enter, 8, enter, 9, enter. Now, I'm going to go under this X at an empty cell, okay, somewhere, and I want to do a linear regression only with this information. How do I do that? Go to menu, come up with an equation for just the X and the Y. So I can come up with a linear function in slope-intercept form from this table right there. Even though I have everything in my calculator, I only want to use that X and that Y. So I go to statistics, then I go to stat calculations to do a linear regression in slope-intercept form from what? My time and tree 1. Now remember, what did we label time in our calculator? X. What did we label tree 1 in our calculator? Y. So I'm going to do a linear regression. What was X? X. What did we label our Y list for tree 1? We just said that was tree 1? No, we said that was Y. And then just hit enter. Okay? It may overwrite data in the columns. Do you wish to proceed? Yes. Okay, so what did I get that equation to be?
1.5.
All right, so write that down underneath it. To be 1.5 X what? Plus 3. We give it that? Oh, darn it. I shouldn't have. I don't know why I didn't go to an empty cell. I did, but I didn't hit enter, so it overwrote stuff. Dang it. Okay, so I'm going to do that real fast again, okay? We know that equation, right? So did y'all go to an empty cell and y'all's is okay? Y'all's didn't say it was going to overwrite? It did too? Oh, okay. Anyways. Well, we could have done it again if I would have put it over to the right. I don't know why I didn't hit enter whenever I went to that cell. It's okay. So we're just going to do another regression. So start over. Okay, and we're going to do an equation for tree 2. I was going to show you a cool little feature, but I'm not. Let's just go to new document. Don't save your last. Add your list and spreadsheet again. So we're going to table list X, or title that X, and this is Y. And so my X's are still the same. It's 0, what? 1, 2, 3. I was just trying to shorten this up so you wouldn't have to do it twice. It's okay. And then my tree 2 is at what? 6, 7, 8, 9. So I'm just coming up with an equation for this one now. And then come to an empty cell to the right somewhere. Okay, let's do it over here so that way we don't overwrite our data again. And then go to menu, statistics, and do a stat calculation. Do a linear regression in slope-intercept form, which is number 3. X is X, Y is Y, and then just hit enter. So what's my second rule? Y is equal to my slope is 1x, my y-intercept is a positive 6. So there is my system of equations for that table. Which one says that? Y is equal to 1.5x. Do I see a 1.5x, 1.5x? Yep, right here. 1.5, or y is the height. That's the same thing as y. X is the 1.5 plus 3. And then if there's not a number in front of your variable, same thing as a 1. So it'd have to be d. Okay, let's look at 2. Which best describes this system of equations? This one here. Is it going to have one solution, no solutions, or infinitely many? We'll just graph it. So let's do that. Enter calculator by going to new document. Don't save my last one. Add your graph. And then enter this not as a function, but enter it as a relation because it's not in slope-intercept form. So go to graph edit entry. We're going to do that as a relation. And just type it in. It's 2x what? Plus y equals 3. Enter. And then graph the next one by going to tab. That would be 6x equals what? 9 minus 3. Y. And then enter. What is it? They're the same graphs. They fell right on top of each other. These are the same two equations, just in different forms. So what type of a system would that be? Or how many solutions would there be, first of all? Infinitely many, so that would be a consistent system because it has at least one. And it is... No, independent means one. Many means you rely on many, so it would be dependent. So it would be consistent and dependent, which is H. All right, let's look at 3. What's the approximate solution of this linear system at the right? So look at that right there. Tell me where that point is. Y'all know I've seen that on the EOC several times. That's that easy. It'll show you a picture and say, what's the solution to this? Well, it's just where they cross. Where's that point? 2, 4, right? They're counting by 4s. 6, 8. So that would be at the ordered pair 4 what? Negative 2, negative 4, negative 6, negative 8. So that would be a negative what?
1.
Yep, negative 1. Because it's in between 0 and negative 2. So 4, negative 1 would be D. So far, that's not too bad, right, if this is the EOC. What about this one? If this is an EOC question, which cannot describe a system of linear equations? No solution? Yeah, they have no solutions. Infinitely many solutions? Yeah, they have infinitely many solutions. Do they have exactly one solution? Yeah, that is. But which one doesn't? Okay, do you know that you can have a system of equations that has two solutions? They just would not be linear. You understand? So what that means is if you have exactly two solutions, it could be something like a U-shaped curve and then a line. See, they cross 2 times. So that's when you would have that. But not for linear functions, right? For lines, you're either going to have them cross 1 time, or they're going to be parallel, which is no solutions, or they're going to be right on top of each other, which is infinitely many. Y'all got it? All right, so that's your notes for today. So we have a Math Excel assignment. That's your homework for the weekend.